Right now, as this video plays, artificial intelligence is making countless decisions that shape daily life. Your phone predicts what you might type next. Netflix selects engaging thumbnails to entice viewers, and your car's GPS calculates the fastest route home. Yet the roots of this technology trace back over 2,000 years to ancient Greece, where inventors crafted automata, mechanical servants, designed to pour wine and open doors automatically. The journey of artificial intelligence began long before the advent of computers. In ancient Alexandria, brilliant inventors created mechanical birds that could sing, automatic doors that opened upon approach, and even robots that served drinks at lavish parties. These creations were not mere magic tricks. They represented humanity's first attempts at building machines that imitated life. The Greeks referred to them as automata, meaning self-moving things. They envisioned creating artificial beings so lifelike that distinguishing them from real ones would be nearly impossible. Creating artificial life raised a fundamental question that continues to puzzle scientists and philosophers alike. What exactly defines intelligence? Consider the workings of your own mind. You can recognize faces, solve complex problems, learn from mistakes, and generate new ideas, understand language, feel emotions, and make decisions based on various factors. But which of these traits truly encapsulates what it means to be intelligent? This question became pivotal as scientists began constructing thinking machines. Some theorists believe that intelligence comprised a variety of mental abilities. For instance, one person might excel in mathematics but struggle with musical skills, while another might be adept at reading emotions yet have no sense of direction. This concept, known as multiple intelligence, suggested that intelligence is not a singular quality, but rather a collection of diverse capabilities. On the other hand, some researchers took a different approach. They viewed thinking as a form of computation. Imagine your brain functioning like a complex computer that processes information, stores memories, and executes programs to solve problems. This perspective, known as computationalism, proposed that thoughts could be distilled into mathematical operations, similar to how computers perform calculations. This idea isn't as far-fetched as it might seem. Everything in the digital realm ultimately boils down to simple binary choices, yes or no, 1 or 0. Every photo, song, or video that brings joy exists as combinations of these two numbers. This binary code serves as the foundational language that computers use to represent any type of information. But how do these ones and zeros translate into intelligent behavior? The answer lies in algorithms. An algorithm functions like a recipe, providing a computer with a precise set of instructions to follow in order to solve a problem. When you search for information online, post a photo on social media, or use a GPS to navigate, an algorithm determines what happens next. Algorithms are powerful because they excel at breaking down complex problems into simple, step-by-step instructions that even a machine can follow. Need to find the shortest route to a destination, detect a cat in a photo, or translate a sentence from one language to another? There's an algorithm designed specifically for that task. The real magic happens when these algorithms work together in what is known as computation. The process of taking raw data, applying specific rules, and producing useful results. Your phone performs billions of computations every second to create the smooth, intuitive experience that users have come to expect. This computational approach revealed something astonishing. Many tasks that seem uniquely human can actually be deconstructed into logical steps the machines can execute. From playing chess to diagnosing illnesses and even creating art, the possibilities are vast. However, the true intrigue lies in the realization that building intelligence wasn't solely about faster computers or more sophisticated code. The real challenge was teaching machines to learn and adapt, much like humans do. Think about the process of learning to ride a bike. No one provided you with a detailed manual. Instead, you tried, fell, adjusted your approach, and gradually it became second nature. Your brain learned through experience and adaptation. Researchers recognized that true artificial intelligence would need to learn in a similar fashion. Instead of programming every conceivable rule, they needed to develop systems capable of recognizing patterns, learning from experiences, and improving over time. This insight transformed the landscape of AI research. Scientists began creating algorithms that could modify themselves based on the data they encountered. These learning algorithms started with basic skills and improved through practice, much like a human would. The results have been nothing short of remarkable. AI systems can now play games better than world champions, recognize images with greater accuracy than humans, and even generate original stories, art, and ideas that challenge traditional notions of creativity. What began as a dream of mechanical servants has evolved into something far beyond what those ancient inventors could have imagined. The algorithms powering today's devices are descendants of those first automata, but with one crucial distinction. They can learn, adapt, and grow more intelligent over time. And this is merely the beginning. The next significant breakthrough in artificial intelligence may be unfolding right now in a laboratory, building on the same principles that were established over 2 millennia ago. The pressing question isn't whether AI will evolve, it's how quickly it will surpass everything humanity thought was possible. The journey of artificial intelligence is just getting started, and its future holds limitless potential.